Okay, so I'm just going to do a test separation using the latest version of audio-separator with a couple of different models. So this is a model that I know is particularly fast. So once it's downloaded, I'm running this in debug mode, and I should note that this is using the very latest version of audio-separator, which is 0.19.1. And it's using a recent version of Python 3.11, not the newest, not the oldest either. I do generally recommend a recent version of Python, and it's running on an Apple MacBook M3 with an M3 Max processor. So that, for a 3-minute song, took a total of 20 seconds. And as you can see, it was using the GPU, because you see the spike in the GPU usage graph here. If we do the same for another model, so I'm going to use the BS Reformer model. This kind of verifies that different models take a different amount of time. You want to make sure that they're using the GPU ideally, so that's I've put a good bit of work into making sure that audio-separator works with GPUs where it can. I've done most of the testing on my own Apple MacBook, so I've been making sure that it works with Apple Silicon. So you should see the GPU usage graph as we're seeing here. And in this case, we're looks like it's going to take about 1.5 minutes for this song. So this is a heavier model. This isn't as quick as that previous one, which took only 20 seconds. Let's give it a second to run. And once this completes, I'm going to use one other architecture to demonstrate. There's different model architectures that use completely different implementations and different ways of accelerating. So neither of these ones that I've just shown you here use ONNX for the model, and that's relevant because the models which use ONNX runtime use a different method for GPU acceleration that relies on ONNX runtime having GPU support. So I'm going to run one of the MDX models after this. Done. One more iteration. And this is going through the different chunks of the audio file that it's processing the separation for. So that took him 1 minute and 51 seconds, or just under 2 minutes for a 3-minute track. So it's not the fastest, but it is one option. I'm just going to show you... Oh yeah, there's actually one more model I wanted to demonstrate first. So this is another model I use a lot, which is an MDX model, and it's one that's designed to oh my bad, I used the wrong file name. It'd help if I use the right file name. So this one is Cara 2. So this one tries to keep backing vocals in, but it's another one of the MDX models, so it's fairly fast as long as you have the MDX separation. But you can see over here that this one still uses a lot more CPU on my machine anyway. In fact, actually, I guess the MDX, the ONNX acceleration isn't working on my Mac right now, because otherwise that would have installed, that would have been using my GPU. So it's important to pay attention to if it's using your GPU or CPU. I guess this one wasn't using my GPU, as we can see from the CPU graph. And why is that? Actually, let me just double check, see if I can figure out why. So, and now I ran this in debug mode, so there's a ton of debug output. So the ONNX runtime. Interesting. Okay, so ONNX runtime did actually try to use CoreML, but it encountered an error. So in theory, that should have worked to use my GPU, but the yellow line that I paused on for a moment in these logs showed that the ONNX runtime wasn't able to use the GPU for a reason that I'm not going to go into detail on. It's kind of complicated, and I'm not sure I fully understand it either, to be honest. ONNX runtime will fall back to using the CPU if it can't fit a certain shape into the number of nodes available to it on the GPU. I'm going to try one more model just to test something. So if I list models, there's another MDX model I wanted to demonstrate, which is inst HQ4. So if I run this again, that looks like it's also using my CPU. So I guess right now, sorry, the ONNX runtime models aren't working on my GPU for whatever reason. I will figure that out later. I think there's another MDXC model that's worth testing quickly. But I mean, even when they're running on my CPU, you know, these models don't take a long time. Like these ones take, what, 30 seconds for a 3-minute track, which for me anyway is fine. For my use case anyway, you know, that took 36 seconds. I am going to try the inst. What do I mean? This model. So this one is a different architecture entirely. This is one of the MDXC architecture models. It's actually a very good model, very clean results from this one. This one was my go-to for a long time. It does much better with higher frequencies as well. Obviously you can ignore the download time because you should have that cached already. I just don't happen to right now. So this one is a heavier model. It normally takes a longer period, but you definitely want to make sure. So you definitely want to make sure this has GPU acceleration working, and the GPU acceleration is obviously working for mine. By the way, these GPU history and CPU history graphs, they're just part of Activity Monitor, which is built in on every Mac. If you go to the window and you click on CPU history or GPU history, you can enable them like that. It's really useful for identifying what's using your CPU and what's using your GPU. You know, so with this model, it's using my GPU fully, and it's also using a decent amount of CPU. But it looks like it's still going to complete in just under 2 minutes. You know, we can see that from the estimated time here. So I'll put all these times into a message just to kind of reassure you that, well, first of all, give you some data to work with so that you know what to be aiming for. My expectation is that, you know, different models take different amounts of time, but as long as it's using your GPU, which it should be for most of the models, it should take, you know, no more than a couple of minutes to inference a 3-minute track. So there's something weird going on with the 7 minutes that you experienced, but I'll happily help investigate that if you can provide me the sample file, or we can do a bit more diagnostics. My first gut feeling is that upgrading to the latest version of Python and the latest version of audio-separator is worthwhile, because there's been a few changes in both things since then. In fact, now I think about it, I think the version of audio-separator you're using, 0.18.0, I suspect the BS Reformer model wasn't using GPU on ARM machines in that version, because I think we fixed that in 0.18.3 or something. I might be misremembering, but definitely try upgrading to the latest version of audio-separator, because you might find that then it starts using your GPU and probably a lot faster at that point. Yeah, it still shouldn't be taking 7 minutes, even if it's using your CPU, but with a heavier model like this one, or like the Reformer models, you might find it be a little bit slower. I'm just going to let this complete because we're almost there. And there we have it. So that was actually the slowest. That took 2 minutes and 37 seconds in total, despite using my GPU fully the whole time, and also a good chunk of my CPU. But, you know, I already know that is one of the heaviest models that audio-separator supports. But yeah, so less than 2 minutes should generally be normal for a 3-minute track. I'll send you all these details in the GitHub message, and good luck. Cheers.